Hello, everyone. My name is Vladimir Baranov, and I'm a CTO of Advisor Engine. And I'm here to do a quick overview of our stack slash architecture and how we're using different technological solutions inside our company. I thought this fancy background would liven up your day, and this wonderful hoodie will too. All right, why don't we start? I will do a full screen present. All right, it's loading. Just give it a second, please. Okay, I think we're ready to go. And once again, I'm Vladimir Baranov. I'm a CTO of Advisor Engine. We produce software for wealth advisors. Jumping in of what's going to be layers that I'm going to cover today, I'm going to talk about our networking, processing, storage, reliability, and security layers. Let's start with networking. Everything is based on networking, and we are using FortiGate firewall with all the built-in security features in order to connect all of our boxes together. Connected with that, we also have Duo 2FA for all our internal connectivity, and we're using Nginx for web serving, and we're using CloudFront for CDN and also for filtering. Some of our clients require that we block access by certain IP address only accessible to them. All right, so moving on. The next layer is processing. I kind of put together all the technologies that we use for all the request processing, and this is generally where all the programming and the code will go. And we have a lot of code, call it the full alphabet of C#, PHP, Java, Scala, React. A lot of it is legacy related and code that came to us through acquisitions. So what we were trying to do, and we're still trying to do, to merge a lot of it as possible in different domains where we can. We have already successfully merged all the infrastructure onto a common AWS stack. But here you can see that we still have a lot of business logic available in C# and PHP. Our front end is covered by React. We do receive batch files regularly from financial institutions. So for that to be processed, we decided to implement a big data solution with Apache Spark, and we are trying to migrate that over to AWS for better scalability. And as you're probably familiar, Spark is using Scala for the coding of the batches, and that's what we use too. For packets for the bus, we leverage RabbitMQ, which is a pretty good packet management system. Then for all of our jobs and all our scheduling, we moved away from cron completely for most of our solutions, and we are just using Jenkins for all our environments. All right, moving on. Storage. So this one is pretty straightforward. We're using EFS, Microsoft SQL, Postgres, and Redis. We are trying to migrate everything away from Microsoft SQL Server over to Postgres. And again, as I mentioned before, a lot of this storage came from different legacy configurations, and it's in different places, different databases, and we're trying to aggregate it across time, and probably going to take us a few years to get to the final end. We're leveraging Redis for some of the value key storage information that we have, things like session management, and also some other parameters that we need to store only temporary. Then you leverage EFS. We found it pretty useful to share data between multiple nodes of our execution environment. So we mount that directly onto our execution nodes. We found it pretty helpful. And for those who are not familiar, EFS is the AWS version of the network file storage. And we mount it directly on our EC2 and nodes. All right, moving on. Reliability, so that's basically where DevOps lives. We use a lot of tools to make sure that our production doesn't go down, to maintain certain numbers of to maintain the SLA, and to make sure that we're able to access all the logs and debug as the time when the right time comes. All of that rides currently on Kubernetes. We do maintain multiple EC2s still due to legacy issues, but we're probably around 50% now on Kubernetes on the native AWS EKS, which we're very happy with. We use a CloudWatch to monitor many of our AWS assets, and we also use New Relic to do things like synthetics and monitor APM, which is not available in open source version. Then we use tools like FileBit and Telegraph to take stats from our servers and send them over to Grafana. Grafana is our primary aggregator of all the reliability data. So this way we have a single pane of information for anything and everything that is going wrong or right in our system, and we're able to see it in Grafana. For log aggregation, we use Splunk and Elasticsearch. The reasons why we have two is because we do have certain external vendors which need access some of our logs, so that's why we're still maintaining some of the Splunk access. We decided to shift also to our internal version and host of Elasticsearch because we found Splunk to be quite expensive, and when we were considered using Elasticsearch, which comes directly with AWS, it also came out to be quite pricey. So right now we're just hosting Elasticsearch directly on EC2 nodes. And all of that is being monitored by PagerDuty. So in Grafana, we set up all the rules, and whenever those rules get broken, PagerDuty gets notified, and then we all get notified, whoever is on duty. All right. Moving on. Security. That's one of the other very important components of our architecture. We try to introduce multiple layers here, so to make sure that we don't get penetrated, our data is not get stolen, and all of our users are well trained. So starting with HashiCorp Vault, we use that for storing all of our secrets. Each of the environments has its own HashiCorp Vault. We don't have any passwords or API keys or usernames parameterized. I mean, all of that is stored in the HashiCorp Vault. And if that accidentally goes down, or if it goes down on purpose, then all of our applications are locked out from secrets, but that also adds a level of security when there is a break in the application, that the passwords are not being accessed at all. Then we have Tenable IO. We found Tenable to be very good for doing vulnerability scanning on our EC2 machines. We have a passive scanner, basically, which logs in, active scanner, which logs in through SSH to all of our boxes and checks vulnerabilities against the outstanding ones. And we really like the reports that Tenable produces. We're not very big fan of it for for just a regular web scanning. For web scanning, we actually use Qualys. We found it to be more comprehensive when it comes to web penetration automation, and we currently use that for all of our applications. It's a little bit more difficult to configure from the ground, but once you get it working, it's quite comprehensive. Then WebRoot is our standard antivirus that we use on our servers and also on end client machines. Then we have OSAC for monitoring any assets within the machine that might be modified. So it's a very useful tool for that, with all the different rules and notifications that could be set up. Then we use Cisco Umbrella for internet for internet filtering. So basically, we can just whitelist or blacklist certain DNS. So that way we protect our users and our environments from those URLs. We employ an outside vendor called Braintrace for our SOC, Security Operations Center. So they constantly monitor our access logs and also maintain our firewall versions. And for human error, for users, we used them before for security training, but also for regular phishing simulations, which we found to be very useful in order to maintain a level of readiness amongst our users in case something gets distributed that they shouldn't click or shouldn't forward. And that way, when actual real threat arises, all of our users are ready and prepared. All right, I think that is that. And again, thank you for listening to my quick presentation. Let me know if you have any questions by just emailing me at Vladimir@advisorengine.com or finding me on the 7 CTOs Slack, and just reach out to me there directly. And with that, Etienne, thank you very much for organizing this conference. Happy to present in it. Have a good one. Bye-bye.